cross section, and now we have to verify with geosine. Okay, I just summarize about the input, and you can calculate it and try geosine software. Okay, Go5 version 2020. I use a 3 version, and you can check. I just input material for the soil layer, assign it, and I had to apply load. You see here, this is a normal force. We can include it for the normal force, for the moment in both axis, for the horizontal load. Okay, at the pi height, you can input all information. Now we had to input in normal force, and we will verify with our Excel. And you see about geometry, the diameter of the ball pipe is 1 meter and length is 25 meter, and the cross-section type is circular, and material pipe is concrete, and technology type is ball pipe. And you can input here pipe height, offset, dip. Okay, from here, from the ground, from the soil to your pipe height offset is 2 meter. Okay, you can see here. And for the material, we apply 30 megapascal for the concrete and 400 megapascal for the main rebar, and 240 megapascal for the C rebar or for the link rebar. And after you input all the parameter, now we have to verify vertical load. You can see here, but we don't want to focus about the soil bearing capacity. We want to focus about the rebar design. Okay, now let's start. It is a settlement. You can check here in geosine. Geosine also have ability to calculate the bearing capacity of soils and settlement, and with the bearing capacity or the cross section. You can see here some right design. This one for the modulus, and this one for the displacement, for the shear, for the moment. And you can input moment. You will check about the moment. Okay, if I input it 50, and after you check it again, you see here the shear force and the bending moment, and this is the displacement. You can check everything by input. In the case I had input for the okay, I can input it for the actual load only. Now we have to verify it. The bearing capacity of the soils is more than 70 factor 2 is okay. And for the rebar, now we talk about rebar. Okay, you can see here, you find the maximum value automatically for the calculation, and verify indifferent or maximum effect. Okay, the maximum effect we verify in type pi. Okay, in type pi. And now I have to input a little value of it. You can input 20. Okay, you can input as actual your analysis, but in the case I just want to introduce you about how to check the rebar. Okay, you see, you have to input the pi reinforcement. H cover is 25 millimeter, and diameter rebar is 20. We don't have additional rebar, and reinforcement ratio is pi. Okay, you can design its R column, you can design it R pi as you want. And we include the C rebar. Okay, C rebar diameter is 6 millimeter, and spacing from one rebar to other rebar is 100 millimeter. You check here, this is the shear ratio. It is the bending plus compression is 4.3%, and the reinforcement ratio is 95.5. Okay, accordingly we apply this load. Okay, this load of 2000 kilonewton, and with moment 20 kilonewton meter. But in the case I want to verify is by take this 0. Okay, now we have to check it again. Okay, you see here, it is the shear ratio, it is the bending plus compression. Okay, it's around 14.4%, and the reinforcement ratio is 95.5%. What does it mean 45.5%? You have to verify this value with the limit of the reinforcement here. Okay, you have to make sure your cross section is less than 0.5. You have to input at least 3 bar in your section is 0.5%. If your cross section in range here, you have to input your rebar section is greater than 25 square centimeter, and for other one is your concrete cross section is more than 1 square meter. You have to input rebar is 0.25% of your cross section. Okay, this is the value that show in here. Okay, you see here the bending plus compression is 14.4. Now we check with my Excel. You see here for the ACI code we got 15%, and for the BS or CP4 is also similar. Now we can to check more detail. Okay, what is different? Okay, you see here for the ACI, one for the BS and CP4. Okay, you see here for the bending plus compression we got this value, and for the reinforcement is 95.5%. Okay, 99.5%. 8 dB 20 for the cross section 1 meter. 8 dB 20. You see here our cross section of rebar is 2513 square millimeter. So you have to make sure your concrete section is 0.7 square meter. 0.7 square meter. You have to check here. Okay, this section is in range here, so you have to use your rebar mass greater or equal to 25 square centimeter. Okay, you check here. Okay, our section is 2533 square millimeter. You see here the limit is 25 centimeter. Okay, 25 centimeter the limit. Okay, now we have to verify by U25 divide by the value with 25.13 you will see here the ratio. Okay, the ratio of rebar is 0.99 or 99%, and you see here it is 99.5. You see here, this is how the geoscience or geophy calculate the reinforcement ratio. It's not the ratio of the rebar working under load, but it's the ratio of rebar in the cross section. Okay, now we have to verify. I had to increase the load from this to other value twice, and you will check this ratio change or not. We will be see the bending and compression will be increased, but this ratio rebar is the same. Okay, now let's try from 2000 to 4000, and we have to check it again. Okay, so the bending ratio will be increased, but the rebar ratio not increased. I told you it's not calculated based on the load, but it's the percentage according to the cross section. Just to verify with the limit. Okay, limit of the value. Okay, you have to check here. I just verify it for you. You can see here the value will not change. Okay, but you will see here 28.8. Now I have to increase the load to 4 also. Now we will check. Okay, 4 also 4000. If we check, the ratio is around 29.83%. Now we have to check here. Okay, it's 28.8%. the compression ratio in geoscience. Okay, you can input moment, you can input for actual force, and you can check it. You see everything is a comparison between manual and with how the surveyor calculate. We see here, and if you continue to increase loads, okay, more twice, okay, H, you have to check about okay, the bearing capacity of soil is says, okay, because it greater than the limit value is 2, the safety factor. And for the rebar, it's not change. Okay, it's not change, it's the same, but for the bending and compression it increase more. Now we start to H. Okay, you will see here H, okay, around 60%, 60%. Okay, is similar with the geoscience, and you have to measure. In the case is bearing capacity of concrete is control. Okay, it is greater than soil. But if you continue to increase the load, what is happen is I increase it to 10.0. You will check here. It is very important. You can see here, in this case, the bearing capacity of soil is less than 2. What does it mean? It less than 2, it means your soil cannot resist load anymore. So in the case, we have to limit the bearing capacity of our section to the minimum value at the soil. Okay, at the soil. Okay, you have to limit your bearing capacity of concrete. So we choose the bearing capacity of soil to control our design. Okay, to control our design, to make sure you use the minimum, or the concrete strength and the soil bearing capacity. Okay, the concrete bearing strength and soil bearing capacity. It is very important for calculation. Okay, and you don't forget about the limit value of concrete is only 30. Okay, 30 megapascal according to CP4. Okay, you have to check about the limit. Okay, CP4 is 7.5 megapascal for allowable stress. It is very important to check. You should check the limit concrete stress. Check the. You have to select the minimum of concrete section or soil bearing capacity. To make sure your concrete can resist load and your soil also can resist load. And if your soil cannot resist load, so you have to reduce your concrete strength to soil bearing capacity. You have to make sure everything is set. Okay, in this case we cannot take the bearing capacity of concrete, so we limit it the bearing capacity of the soil. Okay, so you have to check it again. In this case, what you see, the compression is around here and around here. Now we have to input the moment. Now I try to input the moment around 50, and we check the diagram again. You see the displacement, the C, and the bending moment, and the bending plus compression is 10.8. You can see here everything. Now I will compare it with my Excel again. Okay, you can increase it to whatever you want. Okay, 100. You can see here. Now we ignore this. We just to focus on the rebar anymore. Now you see here, it is the compression plus bending. So what does it mean? It design a cross section. Okay, a cross section. It not design as column. Okay, you have to design all cross section, and you apply the cross section by internal load, by moment, by end, by shear, and you design this cross section. Okay, now we have to check with our sheet, one more sheet. Now I have to include input everything here. This is based on the Eurocode, and we have to change the material and coefficient 1000 millimeter. Okay, and for the cover 75. Okay, and we use 8 dB. Okay, to make sure everything is the same, 8 dB 20. Okay, now you have to check here. You have to check here the bearing capacity of our section. By on we use the concrete strength. Okay, here for the Eurocode and rebar strength, and you will see everything. Okay, you will see everything here. Now if you input, okay, you input the same load. Okay, the same load with this one. Okay, 10,000, 10,000, okay, 10,000, 10,000. Now I have to input it. We do not want to focus other section. Delete it, delete it, delete, 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 delete. Now we just put is 10, 1, 2, 3, okay. And the moment, for the maximum moment, you can see here is you use 8 dB20 is still says, okay, for this section, okay, for this section. And for this strength of concrete, here I use the same, is 30 divided by 0.85, okay. You will see here, okay, this is our rebar, the 8 dB20. You see here 8 dB20, a diagram is here, diagram is here. So it's this says, okay. But actually for the single pie never reach this maximum value, okay. You have to check everything to make sure you input the correct data, okay. The correct data, you will get the correct answer, okay.